Hello all. Today we are going to talk about an important factor, that is population forecasting. Before I get into the topic, I kindly request everybody to like, share and subscribe to my channel, and please kindly comment with your suggestions. I will try to incorporate your suggestions in upcoming videos. Thank you. With that, let me start with my topic. So whenever we are assessing the water demand, or we want to build a huge STP or a centralized effluent treatment plant or a centralized sewage treatment plant, one of the factors that has to be considered is population forecasting. Generally, the design periods of different entities such as dams or pipelines is from 40 to 60 years. Then treatment plants, STPs. So generally they are designed for 20 to 25 years. Similarly, the distribution systems, they have a design period of around 20 to 25 years similarly. So uh, so basically whenever we want to for we want to design something for the future, we need to have a better guess about the population which will increase. Now there are three types of cities which generally we look for when we are designing. The number one is the stagnated cities, where the development is not much and the growth is not that considerable. Then second is the younger or new cities which are having a growth rate in exponential side. Younger cities, or you can say new cities. And third one is fairly those cities which are reaching their highest growth, or average size town, we can say. So how to basically predict the population for such cities? Okay, so let me get to now. Let us first discuss stagnated cities. So generally, arithmetic mean model is used in case of stagnated cities. The model says dp upon dx is equal to n, which is constant, and if I solve, I will get Pn is equal to P0 plus Nx. So Pn is the population after n decades which we want to plan for. So population after n decades. P0 is population at the end of last known decades. So population after end of last known decade. Last known decade, or easily I can say last known census. So that value we have to take in place of P0, and then n is definitely number of decades between now and future. Number of decades between now and future, and x is given by average population increase in between decades. So this is the arithmetic model which is used for the stagnated cities. So let me write the equation for the younger cities now. So as I said, for the new and younger cities, so we have a geometric model, the geometric increase model to calculate, and that is given by, so Pn is equal to P0 into 1 plus R upon 100 raised to n. So I am just adding one more parameter here, that is R, which is nothing but the growth rate. And lastly, uh, we have the incremental increase model, which is suitable for our average size town. So for average sized town, we have incremental increase model. The equation is given as Pn is equal to P0 plus Nx plus n into n plus 1 by 2 into y. So you can see that if you compare the arithmetic mean model and incremental increase model, so this is what the incremental increase factor is, and here the y denotes, so y denotes average incremental increase of population in known decades. So that's how the population is generally predicted. And remember that the incremental increase is determined for each decade from past population, and average value is added to the present population along with average rate of increase. So that is the difference between arithmetic mean and incremental increase model. So friend, that's all for today's lecture. So I will try to I will try to show a couple of examples in a separate video using an Excel sheet of how we can actually calculate using this every model. I will try to do that in the next upcoming lecture. Thank you.